Hi, everyone. Whoa, that's loud. Hi, everyone. My name is Mano Marks. I'm a developer programs engineer here at Google. And contrary to all the previous sessions, probably, I am going to actually try and start this on time. What I want to do is first, the little housekeeping things. One is there's these little evaluation forms. And if you could return those at the end of the session, that would be really helpful. And we really actually take a pretty hard look at those and see how different presentations go. So the other thing I want to do is thank you. This is it. This is the last session of the day. Thank you for coming to Google I/O, you guys. I've had a fantastic time, and I hope you did too. So thank you. So before I get started with my slides, I want to just do a little overview of what I'm going to do today. I don't know, maybe I did when you do slides 2 days before and then you don't look at them for a while, you sometimes forget. I'm going to do, in this talk, I'm going to do an overview of like what am I talking about? What am I talking about with hosting your data, and what are some of the kinds of things that you want to do, you want to look at, some of the options. And then I'm going to give some concrete examples. I'm going to use three different services as examples. One is PHP MySQL, and I'm going to give 2 different examples from that, so some fairly simple ones of doing spatial queries. And the reason I chose PHP MySQL over something like PostGIS, which is actually like this really ubiquitous not ubiquitous, this really powerful GIS tool, is because PHP and MySQL are installed on hosting environments all over the world, and they're very easy to get started with. There's huge developer communities around them. I'll give an overview, so I'm going to use that. I'm going to give a GeoServer sample. I'm just running through some of the demos that they give, and I'm also going to show you an option for running on Google App Engine, and a sample application that Pamela Fox and I designed, and it's an open source application that you can then sort of take and run with. So I'm also going to give like a really quick overview of what some of the other options are that are out there. If your favorite hosting environment, your favorite databases aren't mentioned, your favorite tools aren't mentioned, I'm sorry. There's tons of great open source resources and commercial resources out there. So as I said, I'm going to give an overview of what some of the options are, give you a few concrete examples. That being said, before I actually go too far into it, this has been a long day, and yesterday was a long day, and a lot of the sessions start out with somebody giving 20 or 30 minutes of talks. I want to see if there's some things that people are coming into this session with questions about, and maybe I can say, oh no, I'm not going to talk about that, or I can be sure to include at least something about that during my talk. So there's a microphone right there, and why don't we just spend a few minutes? If you have any questions before I get started, please do. So anyone? Somebody's got to have a question. There you go.
Just to get the ball rolling, and I like the concept, so thank you for doing this. I'm just more interested in optimization, so like architectures for conditions in which static hosting makes more sense than dynamic, and vice versa.
Okay, I'll talk a little bit about that, definitely at the beginning. Yes?
Working with a client that's a Google Earth corporate or enterprise owner, and they're looking at how they're going to handle their data publishing cycles through Fusion and out to the server. So really the dividing line between what is a dynamically loaded KML file through network links and things like that versus what's going to be pushed through their Fusion server and made part of the the skin of the globe.
Okay. I'm not going to cover too much the Fusion server, largely because that's an enterprise product and it costs a lot of money, so it's not available to most people here. But there are people in the audience, and if they're dared to raise their hands, who know anything about enterprise. No, actually, there's Sean here knows a little bit about the enterprise client. And the other thing you can do is talk to us afterwards, and we can maybe connect you with people who know a little bit more about it. Yes?
Sure. I was wondering about, like Google Maps allows you to cache their data, on a portable device. So when you're disconnected from the network, does Earth allow the same thing?
Is what the same thing?
Do you allow caching of your data on a portable device? For example, I have a Windows handheld. Can I cache data from Google Earth on there when I'm disconnected, to use it while I'm disconnected from the network?
Yes. So Google Earth has a cache in it, and NPU can use that cache when your laptop is not connected to.
Okay. How about on a this is on a non-Windows device. How about on a non-Windows device? Say you have a Palm Pilot and you want to cache your data on that. I mean, is your data?
You mean a non-Google? Oh, are you talking about the new Google Earth plugin?
No. I'm just talking on any arbitrary portable device.
Okay. So the Google Earth client doesn't run on most arbitrary portable devices. So if you're talking about specifically Google Earth, but if you're talking about Google Maps.
No. I mean, the Google Maps will let you, they'll let you cache the tiles. I mean, you can actually copy the tiles from, I did it on another product. I mean, do you have a similar type of thing that you can do with Google Earth for doing a field mapping product?
So no, the cache from Google Earth does not run on any other application. So it's not cached as a bunch of image tiles. It's cached in our specific Google Earth binary cache format. So what some people have had some success doing is going and caching a bunch of data and transferring it to the cache to another device, but another device that also runs Google Earth. But I don't recommend that because it doesn't work very well across different operating systems and different processors. So.
Okay, good.
Yes.
We are working on an application that might end up having to show probably 100,000 different markers at any given point. So we are planning on using clustering. I heard that you guys might end up adding libraries for clustering on the APIs. And if that's not the case, then one of the things that we would like to know is if you have any best practices that you can recommend for doing clustering when you have to show a lot of markers.
Are you talking about the clustering algorithms themselves or how to actually display clustered data?
No, the algorithms, actually.
So I don't know or can't talk about plans to release clustering libraries. As far as for the algorithms, there's a lot of discussion about that on the Google Maps API group, and I think they would probably be the best resource for that. Yeah, I work a lot with KML, and clustering is much less of an issue for us because Google Earth does some default clustering, and there's also just so much higher number of place marks that you can actually store. Yes.
Hi, I'm at a research lab, and our bread and butter is building very compelling demos.
Building what?
Building very compelling demos.
Uh-huh.
And so one of the problems we have is we're very budgetarily constrained, and geodata is typically very expensive if you want to get it from a single source. So I was wondering if you're going to cover at all free or very cheap sources of abundant GIS data, at least for like the US or the Bay Area.
I didn't have that planned in my talk, but I can give you some resources. I know that the U.S. Census is now releasing their Tiger data set, which is what a lot of places resell that data. They've now released those as shape files, which is a lot more portable than their previous format, which was just kind of messed up. That's a lot easier to use, which allows you to use them in things like GeoServer, which is something that I'm going to show in a minute, and in just a lot of different servers will accept shape files, including our Fusion server. Obviously, ArcGIS, which, that sounds like it's not an option for you, or our Fusion server. But yeah, there's a lot of different open source systems that will use that. There's also GeoCommons, although I think right now I don't know if they're actually publishing data at this moment, but they are planning to, again, release a lot of free data, which I think was really good. And then many of the states have their own GIS departments. massgis.org is a really good source for Massachusetts data.
Okay, and one other thing, I was wondering if you would spend just a few seconds talking about the trade-offs between MySQL and like a Postgres, PostGIS approach, and like, because we're thinking about switching over from MySQL to PostGIS, so that would be very interesting. Yes,
I'll spend a few moments on that. Okay, any other questions? All right, now I have to actually give my talk. So this again is the overview. I'm going to talk about some of the advantages of static versus dynamic geo-generation, hosting your geodata in static or dynamic forms. Give an overview of some of the options, which is basically 3 slides of lists of things. And I'll talk a little bit about the advantages and disadvantages. And then I'm going to give some examples of hosting, static files, PHP, MySQL, do a brief GeoServer introduction, and then show the Google App Engine. I'm going to talk a little bit about sitemaps and GeoSearch. So, any questions about what I'm going to actually cover? Okay. Okay, so I like talking about static files because static files are immensely powerful. I think one of the reasons that KML particularly has become has had a really profound impact on the GIS, the geo web, basically, is because you can produce and show meaningful content within a static, just write up a static files. Anybody can open up a text editor and actually do it. Static files basically reside sitting on a server. I'm going to talk a little bit more about this. Dynamic files are generated on the fly. So it's data pulled out of a database, and scripts are generating it automatically. So there's a couple of different options for doing that. One is that you store your data in a database and then periodically generate a file and push it out to a server. Or, on the other hand, you generate it dynamically every time you get a call from a mashup or from another service. Okay, so these are some of the advantages of static hosting. Conceptually, it's very simple. People understand hand editing files. That's one thing I think that we all spend some time doing. It's very powerful, particularly KML and GRSS give you a lot of ability to produce files. You can also statically host. By the way, I'm focusing on XML-based, KML and GRSS, but of course you can do static hosting of any geodata. You can do shape files. You can do geotiffs. There's a lot of different formats out there. Choose your own. Static files are easy to index. You can point a search engine at a file using a sitemap and say, this is my data, index this, and then it will, you will know that if it indexes that file, you'll know exactly the contents of that file. Whereas if you do it dynamically, then, every time you add something to the database, you might want to get it updated. It allows for very deeply nested structures. So of course you can do this with dynamically generated data, but it's kind of easier conceptually to be building very deeply nested structures using KML, for instance. Easily portable. You don't, database transfers can end up being a royal pain. But if you're doing if you're just wanting to send somebody a file, that's the easiest thing in the world. And worst comes to worst, if you've got a really giant collection of data files, you send them a hard drive with those files on it. And it generally requires no additional skill. So the way I like to think about the GeoWeb right now is that is looking back to the beginnings of the web. So at the beginning of the web, there was, before the web really, there was SGML, the Standard General Markup Language, which was immensely powerful. It's really, a really great declarative programming language. But HTML comes along, and a lot of the SGML people think, oh, that's terrible. Who would ever use something like HTML? There's no power in it. But it's conceptually incredibly simple to write up a text document and push it out on the web. And you had, 12-year-olds and their grandmothers putting data onto the web without, doing more than typing things into a text editor. So it's tremendously powerful. And of course, there are also tools like Google Earth and MyMaps, which allow you to do things like create KML files in a GUI atmosphere. Also, if you're a high-end GIS professional, for instance, you can very easily create a shapefile and then push it out on the web. You don't have to think about anymore what you're actually going to do with it. Okay, so here's some of the disadvantages. Static hosting environments can be difficult to maintain. So, if you're constantly having to think, okay, what data do I have to put up there? I have to copy these files. I have to maybe generate a script that produces these files every once in a while, but there's a file out there. You have storage constraints. So, dynamically generated files out of a database tends to use a lot less space than it does to continually be writing files out or hand coding the files and saving them on your web server, for instance. You can also encounter write conflicts. So this is one of those things that people ask me a lot is I have a file that I produce out of my database, and I write out a static file every 5 minutes, and every once in a while I have a network link that pings that KML file and tries to get to it. And if I'm writing over that file, at the same moment that I try and actually grab it, it can cause an error to be returned. It's not truly dynamic. You can't do any sort of querying of that data. So you're basically just putting out data, and people can look at it. They can't interact with it anyway. And I think I mentioned this, you end up with large file sizes. Okay, so some of the advantages of dynamic generation, like I said, more efficient storage. You can do dynamic queries, including spatial queries, so you can do things like, say, I have a polygon, tell me everything that sits within that polygon. Or you can do things like, I only want to see data on rabbit migration. I'm inventing that. I don't think rabbits migrate. But rabbit migration in Lake Town, any state, and instead of getting the whole query, the whole database at once, and you don't have the problem of write conflicts. Some of the disadvantages are that it generally requires a much more varied skill. You either have to have a high-end GIS package, which will produce a certain output in, say, KML or whatever format for you when it's dynamically queried, or you have to write some scripts in PHP or Python or whatever your scripting language is, or Java servlet or however you want to do it to pull the data out. And so that requires that you have knowledge of whatever data that you're keeping it in, whatever database it is. So if you're doing MySQL, you have to know SQL, and you might also have to know the scripting language and how it interacts. It's harder to find a hosting environment. The basic web hosting environment, if you want to rent it from somebody, is here, sure, put your files here. That's Google Pages, right? You can put HTML, you can put other basic files there, and the only scripts that you can actually put in there or JavaScript. And it's a little bit harder to index. So this is not a huge problem. If you went to my sitemaps talk earlier, it's not a big deal, but just, you know, it is one of those things that if you're constantly updating your data, it does mean that you know, the index is going to be slower to find every single piece of your data that's in there. Okay, so I wanted to point out some of the commercial systems that support spatial queries or produce geo data out of them. So Oracle DB, Microsoft SQL Server, they're both things that support spatial queries. Esri's Arc server is one of the big GIS packages, and of course now I think most people have heard that within the next week or so they're going to be releasing the latest version, and that's going to include default KML and Google Maps output by default. So that's a tremendously powerful package. Autodesk, there's actually at least one person from Autodesk here if you want to talk to him more about that. MapPoint, Manifold, there's lots of commercial GIS systems out there. So these are some of the open source systems. There's MySQL, which I will talk more about in a minute. And there's Postgres, PostGIS. Actually, why don't I talk about this now, since somebody asked about this. So the second most common hosting environment out there is the LAMP stack, right? It's the Linux and Apache, MySQL, PHP or Python, or some other P scripting language. And that's why I'm going to be doing some examples from that. It's almost not quite ubiquitous out there in the web hosting world. If you go and you buy your, you know, $3 a month web hosting environment, that's one of your that's almost always one of your options to get. Postgres SQL, I'm always bad at pronouncing this, combined with its extension package PostGIS, is also a tremendously powerful system. Postgres by itself contains spatial queries that can probably get you by in a lot of environments. PostGIS contains a lot more, obviously. So there's some advantages to going with just plain Postgres, which is that it doesn't have to incorporate the extensions, which means it's lighter weight. The PostGIS just produces a ton more, gives you a lot more flexibility in spatial systems. If you have the option to go with this system, with a PostgreSQL or PostGIS, and this is like one of you need something that's open source and you don't want to go with, you know, something that's actually going to cost you money, that's probably your best option. But as I said before, the PHP MySQL, both the community and the hosting environments, it's just far more common, which is why I'm going to concentrate on showing you a couple of examples from those. If you want to know more about PostGIS, I'm going to call out Brian Hamlin, who's got a great video. He and I did a video on dynamic KML generation, and he showed a piece on PostGIS during that video. It's up on YouTube if you want to find it. And there's probably plenty of people who know about it. There's a very active developer community, but it's smaller than the PHP MySQL community who are not tied to just GIS data. So then there's a few other major open source applications. There's GeoServer, which I'm going to show in a minute. There's Feature Server, Quantum GIS, Map Server, the GRASS, which is like the old line. A lot of the other systems are actually based on GRASS, and then there's many other systems. What's that? What's that? CMAP. Okay, yes, CMAP's another one. Right. So I'm sure there's plenty of people here who know more about the different options. Does anybody want me to go over? Is there any questions about the options that I've outlined so far? You know, so far I haven't really actually talked much about Google stuff. I've got another slide on that. Okay, so that's good. So here's the Google tools and products. And I wanted to separate them out because they're not open source, but a lot of them are free or free for a certain, for up to a certain capacity. So there's the Google Earth server, which is not free. That's our enterprise product. There's Google App Engine, which I'll show a sample of, and that's free up to a certain point, and then you can pay per usage. And then Google Spreadsheets, and there's a really great on the Outreach Google Earth Outreach site. There's a great tutorial on using Google Spreadsheets to do KML creation. If I have time at the end, I'll show that. I'm not sure that I do. Google Base is a place that you can store data, and it allows you to do spatial queries based on addresses, but it's not specifically a spatial thing. Also, a lot of other Google data services that we provide the capacity to do queries based on bounding boxes or radiuses. Google Pages is just a place to store static files, mostly HTML, but people do use them for storing KML. And I've seen some people starting to use Google Sites, which is a new product of ours, for a similar kind of thing. Yes, so, right. When I made these slides, we weren't sure we were going to announce that. There is the Google Data My Maps storage API, which I think they've released like some documentation on it, but we haven't really finalized it yet. But yes, that's a really good point. Okay, so when you're thinking about a storage solution, these are some of the kinds of functions that you'd want to look in. These are sort of like basic kind of things that you might be interested in, basic or somewhat advanced. They're things that are very hard to do on your own when you're trying to figure out your own searches. So there's a point in Polygon. This is the basic kind of like, I have this point. Can you tell me if it's inside this polygon over here? So there's a lot of, there's algorithms that you can develop on your own to do that, but you shouldn't have to do that, and that's really difficult. So, it would be really great if your database would allow you to say, hi, I have a polygon. Please tell me if these, any of these points are within it. Intersections, so whether or not you can do an intersection between two polygons, you want to see if where they overlap. Attribute searches, so this is basic for any, I deliberately use the GIS term of attribute, which when you're talking about the XML land can actually mean an element. Anybody wants to talk to me about why that is uncomfortable for me, you can talk to me later, but basically this is a metadata search. This is pretty much any database can do this, right? You can say, give me everything that matches these criteria. There are some, high-end GIS software has some analysis tools built in, so check out a demo for like ArcGIS and see what kinds of things that they can do. Nearest neighbor, like what other points, what other polygons are nearby the one that I'm describing right now, and bounding box searches. So give me everything that is within this range. That's similar to the point in Polygon. Okay, so PHP MySQL, as often happens, I got a little ahead of my slides. So these are, again, I think some of the advantages and disadvantages. Again, that's widely available, lots of enthusiastic users. Many programming languages have hooks into using it. And it does have some built-in spatial queries, which is why I'm going to talk briefly about it. It doesn't natively support most GIS formats, although it does support well-known text within the spatial extensions, and it does support well-known binaries. And scaling is a problem. This is a problem for a lot of databases. I almost said solutions, and I really hate it when people use that word, but it's crept into my vocabulary. A lot of database options will give, you have trouble scaling. Basically, if suddenly you're slash dotted, somebody says, wow, look at this cool mashup, and your server gets pounded. MySQL requires, a lot of effort to do scaling. Believe me, we use it a lot at Google. It's a great product, but you know, this is a big effort. And this will be true of many anything that you're running on servers where you know you have like a server that you're running it on, or 5 servers. You have to plan for the scaling yourself. It doesn't have native GIS output, so that's one issue for people. All right, so I'm going to go into a simple example. This is a simple storage example. This is actually online. Both Pamela and I have written articles against the markers table. But so on code.google.com, you can see there's a generate KML from PHP and MySQL, and there's also Pamela's got a whole series for use with the Maps API. So this is what the table basically looks like: ID, name, address, latitude, longitude, and type. Type is, you know, most of those are what I call attributes or metadata information. But you just put in latitude and longitude as floats. And then how do you actually do the query? Good, that shows up pretty well. Okay, so this is the magical formula. This is just, you know, you can do searches. There's great Wikipedia articles on how to determine within certain degrees certain radius, what coordinates fit in to certain degrees. So one of the big problems, of course, with spatial queries is that latitude and longitude are actually of different sizes when you get into different areas of the globe. So you know they're one size when you're at the equator, but you know everything sort of compacts up when you're up at the top of the north and south, I should say, of the globe. So you have to devise you have to do some geometry. So I don't have like really good math skills. So this is, you know, but you can just find this. This is a well-known algorithms. You change that. See that first number, 3959. That's if you're using miles as your distance. There's other numbers that you can plug in for using kilometers or meters. And then you just do, so I do KML support, so all my examples end up being KML. But you do results, MySQL query, you know, you get a query results, and then you just iterate through and create a place mark for each one. So that's like a really like the simple way to do this kind of data storage and this kind of querying. And I can actually show you an example of this one in action. Okay, so Google Earth allows you to do something called view-based refresh, which is essentially, you say to Google Earth, okay, this particular network link is actually a view-based network link, which means I want you to send a bounding box every time I stop. You send a bounding box to the server and say, you know, and then the server looks at the bounding box and says, okay, I see a bounding box, I know what to do with that. The script on the server parses out the bounding box and then returns the correct results. So I'll show you the KML in a minute, but I want to show you the basics of this. So I activate this, and you'll see here that it returns, actually had it return a limited number of results within a certain radius. And as I move around, it shows me different results. But if I were to scroll out or to zoom out, you'd see there's not many results outside of there. So, but I move here and it's still giving me the top results over. So here's the, right. Okay. So that's your basic view-based refresh using a very simple MySQL. No, this doesn't require any extensions. This was just just showing, okay, every point has a latitude, longitude. It's a really easy example to show. So if I were to do, say, a line string, I'd have to go through each coordinate. You know, I'd probably have to set up a relational table, right? So you'd say, you know, I'd have my my geometry, and it would have, you know, a related table of coordinates. And then you would just do that. You'd have to set up an order on that, and then you'd have to go through and check each coordinate, then check, you know, if you found one that was within the bounding box, you'd go back, grab the actual line, and create out of that. So, yeah, that's all. That's the only reason I did it this way, is just so that I could remove a couple of the steps from doing that. Any questions on? Yes. Could you actually can use the microphone, because it's being recorded on.
Okay, just one little comment concerning your algorithm there, that if you're looking for a little bit more performance, what you could do, if the distance is less than a few hundred miles, you could use plane geometry. So you could just use, you know, x squared plus y squared square root, and it would give you about the same results.
Yes, that's a good point. Yeah, when you're within, yeah. So you're within 200 miles, you said, so you know the math probably better than I. Yeah, certainly you could do that. And I just want to point out, by the way, that I did have a limit of 20, and I'd actually set it up so that it would do a radius within a radius of a certain center point. Okay. So I wanted to give a quick demonstration of simple spatial queries as well. So this is using a table I just call it geom, and it's got a name and it's got a geometry element. So this, by the way, I think is available in MySQL, I think 5.1 and later. I'm not sure exactly which version it came out in, but the spatial element. So you see the type for G is geometry, and geometry is basically a super class, and that you can do subclasses of like point, line, and polygon. And you can do some cool queries against that. So I actually got this, and I should, before the slides are actually put up, there's actually somebody in the KML support group put up a page about doing a simple introduction to this. So I should give that a little credit where that credit is due. I don't actually know his name, I just know his username, and I'm not going to reveal that on YouTube. But if you go to the KML support group, there's a page that describes this in a little bit more detail. So here's the basic query. So you have your query is, and by the way, I should note this is all in PHP, so that's why it's, you know, variables equal things. So select name and then x of g as latitude and y of g as longitude from geom, where, and then there's this function mbr contains geometry from text polygon. So this is basically me saying, okay, here's this polygon. Now tell me what, you know, if these this x and y, which is latitude and longitude, match these, and then match this polygon. So this is just a different kind of query. I don't have an example of this running at this point, but that's how I get that. And you'll see the points in the polygon are actually stored as latitude-longitude pairs. And if you're used to KML, this is actually the exact opposite. This is using well-known text. So you've got polygon. You've got so you see the coordinates are 34 space negative 85. In KML, that would be negative 85 comma 34. And then there would be a space separating the different coordinates. So just have to know that it's the well-known text is kind of the reverse of how we do KML. So, and then the rest of it is actually the same basic results. So I just walk through again, get the latitude, longitude, and create the KML out of it. Yes.
One thing you may note, although it's not going to be a case for since you're querying based on a box,
yes, the
current MySQL spatial extensions don't do the point and polygon algorithm correctly. They just do a bounding rectangle search. And I gather that the MySQL 6 spatial extensions may address it, but at least early testing we've done show that they haven't addressed it yet.
Okay. Well, that's
So
interesting.
yes, but you can write your own. Well, anyway.
Yeah.
But
you can write your own functions to accomplish this. Okay. Okay. So I'm going to do a quick GeoServer example. I see I'm not doing too great on time. GeoServer is actually it's a really interesting example. It doesn't use, as far as I can tell, much in the way of a data store. You can point directly to data and it'll load it in and display it using their whatever formats that they support. So they support a variety of different formats, which I'll show you. They support native GIS formats. Particularly, you can connect it to a PostGIS database right out of the box, and you can do Esri shapefiles, a couple other things, and there's lots of people who are working on writing extensions. So you can there's an active development community around it, and it supports multiple outputs, as you see there: KML, GRSS, Open Layers, Google Maps, WMS servers. It's pretty extensible. You can port it to a lot of different systems. I believe it's written primarily in Java. It's very well documented. It's got like I said, a small but active developer community. And when I first played with it, I had it up and running within like 15 minutes. So when I say it's harder to install, it's actually harder to install on a lot of hosting environments because they just don't support you installing your own software. And scaling, of course, would require more server power. This is the problem with all of these things. So I have a quick demo of this. All right, this is the. I have a couple of demos here. So you can do, for instance, an overlay on Google Maps. This is just a really easy, like they support this right out of the box, and it's going to take a minute to actually connect. Do I have this here? No. All right, it's having a little bit of, here we go. All right, I'm having a little bit of connection issues with it. Oh, I'm sorry, I think I know what the problem is. I need to actually start it. So let me restart my server. I had it running before and it was conflicting with something. So this is just gonna take a minute to run. So there's a few different ways you can use this. One is you can do something like I'm gonna try and show you in a minute, which is it'll set it up for Google Maps output for you quite directly, so you don't have to think about that. Or you can set it up for doing WMS or KML outputs, which basically is it just connecting, the WMS servers are supported natively within Google Earth. They're also basically a way to share images. I think it's started up, so let me see if I've got this running now. So this is using one of their default layers. You see it just works really easily. So I have another example here. This one's a little odd. I just chose to do roads, and I think they're in roads in Tanzania. Is that right? Or no, I had the roads in Tanzania at one point. This is roads. Where am I? I should turn on borders and labels so I'll know. Okay, so these are roads in South Dakota, where, by the way, I was born. Anybody was interested. So unfortunately, this is red and it's not showing up terribly well. You can probably see it better than I am because I'm a little colorblind for red, but it's really simple. Let me show you the KML that points to it. I just loaded this roads.kml file, which was produced automatically. And you'll see the important part is, where is it? Localhost, right here. Oh, how's that getting that data? Okay, so I actually do this in a way that I don't think I would have done it, but they embed this in a CData section. This is the URL. So you can see in there that you're connecting to the local server. You're saying GeoServer, WMS service, service request equals get map, the format. This is the Google Earth MIME type. Then it's giving me a width and height, which is just the borders in pixels, and then the type of coordinate system that it's using, and then the particular layers, KML score, KML attribute equals true, so it's just putting in the attributes, and then the legend, which is false, which is just whether or not there's a legend associated with it. Okay. So, any questions on GeoServer? I'm sorry? It's very simple. There's an admin console, and you just say, "Give me that shapefile over there," or point to this this database. So you just log into the admin. So this is the interesting thing about GeoServer. It doesn't store that data itself. It generates that sort of at runtime. You mean the WMS server or the? Yeah, I think there's a number of different options. Sorry, I don't have. I'm not a GeoServer expert on that, but yeah, there's a lot of really fun things that you can do with GeoServer. Yeah, basically, it's a way of exposing data that you're collecting in a fairly static way, but allowing you to do queries based on it. Yes.
So, you're still limited to what Google Maps can handle, like how the size of the data set and whatnot.
Right. So if you're wanting to view it in Google Maps, yes, that's true. You can also I've seen OpenLayer people using OpenLayers, which is another API, and there's a number of other. So if you're trying to display it in the browser. And you're trying to display things as points, yes, you'll run into that limitation. But it also allows you to do images. So, Brian has a. You want to do a. So I was going to say, while he's getting up, you can also do it as a WMS server, which is essentially a tile server. Right. So you can use it that way.
So GeoServer is big. It's a reference implementation of a huge spec. Of a number of specs, and there's a lot in there. I've only seen it used a few times really in advanced ways, but I know that one of the fundamental features of GeoServer is if you have huge data, tens of thousands on up of elements, then it will automatically decide at a certain point to render an image and ship you the image down, and then when you zoom in, without the interface changing, then it will shift over to geometry. So that's built in, yeah.
Oh, sweet! I haven't seen that. Okay.
Yeah. And there's also that snippet you showed there. I think there's a thing called the KML reflector that it has a different style URL than the WMS service that was on the screen.
Right. So when I just went and got the default KML export that it did. But yeah, you can. There's a few different ways you can.
It's a complex product. It's a big thing.
Right. Okay. So the next thing I want to show is Google App Engine. So Google App Engine is not designed as a GeoServer. I'll just get that out in the open. Google App Engine is designed to allow you to run your data storage on our infrastructure. There's been a lot of talk about App Engine. If you want to know more, a lot of the specifics about it later, you can talk to me. But let me talk about some of the advantages and disadvantages as a GeoServer. One is it does have a native GeoPoint support. This is the same basic model that we use for all of our Google Data APIs. Basically, you can set a GeoPoint which has a latitude and longitude in it. It's highly scalable. So, if you are hit with tons of requests, we deal with that fact. You don't have to write your code in a special way that makes it that much more scalable. We'll just take care of that for you. It's in true Python. I think this is both an advantage, and I should have probably listed it as a disadvantage as well. An advantage, basically we love Python. So Python is cool, man. So sorry, I just had to do that. You don't have to. So anyway, Python has a lot of really powerful functions and libraries. If you doubt me, you can see the comic xkcd, which has some great comics on Python. If you don't know what I'm talking about, don't worry about it. So it also has no rigid database schema modeling. So you can create really extensible entities. So basically, you describe in your code, this is what my entity, this is the model of what it's going to look like, but you can make it extensible so you can add in custom attributes. Basically, at runtime, you can do that, and there's no formal schema validation that you have to worry about. And it has natively some really easy XML output. Basically, outputs things as Atom entries. So doing GRSS is really easy. Disadvantages are there is no native GIS support. It's not designed to be a GIS database. When you're doing a query, you're only allowed one inequality operator. So this is one of those things that you put out there. And it basically requires you to really think in a new way about your data. So this is the flip side of the no rigid database schema modeling. If you're used to relational databases, you basically have to denormalize your data for higher performance. So there's a few other things. If you want to talk to me more about the advantages and disadvantages later, you're welcome to do that. I want to show you a little bit of the sample code. So Pamela and I did a demonstration sample. This is released on open source on Google Code. A geodata store is what we call it. And you can see here the basic. Actually, the Python code, I got lucky. I got to write the back end, which was significantly less intensive than the front end code, which I'll show you in a bit. But basically, I keep wanting to walk over here and point to things, but that's not really going to work. So you'll see here I have this class geometry, and it's of type DB model. So that's just one of the model is just a different default type in App Engine. It's how you do things in the data store, and then you just describe the properties that are involved, and most of the properties are the same as things that you're used to. They're floats, they're lists, there's dates, there's strings. And I have one, you see the coordinates property, which is right here, is a list of geopoints. So this allows, a list basically acts as a Python list, and the coordinates, it's just a list of the geopoints. So I can store a bunch of geopoints in there as a list. So we have built into this a number of different functions, a lot of which are designed, they're mostly Python. The App Engine piece of it is actually fairly small. Most of them are just designed on, how do you output KML, how do you output JSON, how do you output, I think that's all we got, actually. Is that all we got? And then let me go and show you some of the code that actually works the request handler, basically. So this is, most App Engine web apps require a request handler, which basically defines how you handle things like HTTP GET, HTTP POST, that sort of thing. And what we decided to do was handle them GET and POST in the same way, basically takes in the variables and then decides what to do with them based on what operation that you're doing. And we added in the add, edit, and delete options. So your basic CRUD kind of things. And then we just do getting. And let me show you what a query looks like. Let me show you what a query looks like. Where am I getting my query? Here we go. OK. So here I am. I'm building up the query string. And this is in the get geometries. So it looks a lot like this, where something is true and your limit equals something. This is a very basic one. And then we have a couple other functions. I don't have a ton of time, so let me just show you what the actual app looks like. So I've got to log in. Please don't look at my email address, my home email address. And, oh, I'm getting a couple errors. And this may be related to connectivity. OK. So, Pamela, I hope you didn't make any changes on this recently. But I'm getting a little, let me see if I'm getting get the same thing. Well. OK, so we've got OK. I only have a few more minutes, so I'm not gonna spend the whole time on this. Actually, have 2 3/4 minutes. I don't have time to do the Google Spreadsheets example. I have a quick, you can check out the slides later if you want. This is a quick script showing how to actually generate dynamically something without even using a database. It's not something I recommend except for very small projects. And then questions. So, questions. Anybody have any questions? Yes, if you could go to the microphone. Or Amy, I appreciate it. Thanks. Any questions? Yes.
Your Google App Engine, you said GeoPoint support, and you had a list of GeoPoints. Do you actually have polygon support and so forth in there?
So what we did to create polygons was we basically created lists of GeoPoints. Yeah, Pamela's going to go ahead and show App Engine. You got it working? GeoData Store. OK. So yeah, it doesn't. The GeoPoint support basically allows you to do some indexing based on the GeoPoint, which is it goes indexes based on latitude and then longitude first. So.
2 questions. One on the App Engine thing. If you can only do one inequality, does that mean you can't do bounding box searches?
It's more difficult. So I saw a really interesting implementation. Somebody took our code and did GeoData Store 2, and he did it using geohashing. So that's something that you might want to look up. Now, somebody else at Google I/O was saying that he was experiencing some problems with geohashing, but he had some solutions for it. So geohashing is like one of those new things that's, I think, actually the geohashing site went up in February. It's a really interesting thing to look at, and that would be a really good method to use. Cool. You can also do some post-processing. So you do a query, you get back 25 results, and then you go through and knock out, you do your first inequality based on one criteria, and then you knock out anything else that doesn't meet the criteria.
Right. The other question was, do you know if GeoServer supports attribute filtering, which you talked about earlier?
The server supports attribute filtering. So GeoData, you mean GeoData Store?
GeoServer, what you're talking about.
Oh, GeoServer. Yes, it does. Yes.
Okay, cool, thanks.
I know the answer to that. Yes, it does.
Yes. What's the preferred method to get data into the GeoData Store? I don't know, 20,000.
The preferred metadata in GeoData Store?
Preferred method. How do I get my 40,000 parcels into?
Oh, how do you get it actually in?
Yeah.
There's a bulk CSV uploader. So yeah, if you have a large amount of data, you'd have to find a way to convert it to CSV and do a bulk upload. Any other questions? Do you have it running? Yeah. Oh, okay. So this is our example application. So this uses the Maps API as the front end. Of course, we're going to use Maps API, and it uses the new editing tools that you have exposed in the API, which is basically the My Maps editing tools. So, I think really cool. So you see where you have a midpoint between two other defined points, you can pull them out and pull it out and create your own. And it supports natively logins based on Gmail accounts. So you see here that Pamela's one of the administrators, so she can modify any of the things that were created. But if she were some random person who logs in fact, any of you can actually go and create things and store them in there. You'd see only the things that you created could you modify. So these are just things that we thought to put in. You can define your own rules as you want. Yes.
Is the data in Google Maps that you guys store, does that use something like Bigtable like we have access to with App Engine, or is that something different?
You mean in My Maps?
No, just that Google uses. I mean, is there a more powerful tool behind the scenes that you guys use for maps than what we can use in App Engine? And if so, is there any way that might be accessible in the future?
No, I mean, all of our applications run. I won't say all because I'm not 100% certain, but I think almost all of them run on Bigtable, which is what we expose. We do expose a simplified version of that, but it actually doesn't. It's not that there's somehow significantly less power involved in it. It's actually just that we built up a whole bunch of code and we simplified it so it's easier for you to actually use. So, yeah.
Thank you.
Any other questions? Okay. We are over time. Thank you. Thank you all for coming.